Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's webinar, Herding Metrics in Cloud-Native Environments, brought to you by Instana, an IBM company. We have an awesome webinar for you today, but before we get started, I need to go through some housekeeping items with you. First, please note this session is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We'll be sending an email with instructions for how to access the webinar on demand, or you can visit us at devops.com/webinars, and it will be there for you as well. We are taking questions throughout the presentation, so you can use the Q&A tab on your console to submit your questions at any time. We'll try to get to as many as we can at the end of the presentation. If we don't get to your question, however, we will gather them all up and send them over, and our presenter today will follow up with you afterwards. So ask your questions early and often, please. Finally, we're doing a drawing for 4 $25 Amazon gift cards, so stick around until the end to see if you are a winner. All right, with that, I am pleased to introduce to you today Trung Nguyen. He's a principal software engineer at Instana. I'm going to turn my camera off and put myself on mute, and Trung, I'm going to let you get right to it. Thank you.
Thank you, Sharon. Hi, everybody. Thanks a lot for having me here. So my pleasure to present you a webinar about metrics at Instana. So let me represent. So this is the agenda of our talk today. Simple 3 sections. So the first one is about Instana Enterprise Observability Platform. So I will talk about how Instana product as an observability platform. And then we talk about the Instana Agent Operator for OpenShift and Kubernetes. So this will be like a quick mention about that, like how we can use Instana to monitor OpenShift and Kubernetes environment. Also, the talk today focus on metrics at Instana, right? So Instana have collects and process lots kind of data, like log tracings, and our talk today is only focused on metrics. So we will know about like what's behind the scenes in metrics at Instana. So we start with the problem we solved. So what is the problem in the metric space that we solved? And that is actually the motivation why we implement the metric system like the way it is right now. And then we talk about the desired metric capability. So what we want our metric system can offer to our customer. And then the third section, we will dive into like an overview about how we designed our metric system, so from end to end. And along the way, if you have any questions, please feel free to submit it. Okay, so the first thing is about an Instana Enterprise Observability Platform. So Instana is like it's a comprehensive product that can be used to monitor like your whole system. We collect data, different kind of data from multiple sources. So we collect traces, metrics, logs, events, beacons, and profiles. And those data we can get it from. This can come from your containers, your services run inside that. It can be from your cloud providers like AWS, GCP, Azure, and we support like more than 200 different technologies. So that is will cover, I guess, like most of our customer use case. So there is 4 columns here. You see collection, processing capabilities, and use case. So today we will focus on the metric capability here. So in the monitoring section. Cool. So Instana, so we are proud of the capability of automated continuous discovery agent. So we provide an agent where it can easily deployed and automatically monitor your whole system. So the beauty here is that you just deploy the agent, really no configurations, and then it will auto-discover what is there as MySQL, which can discover your Kubernetes environment, namespace, deployment, everything. And we have it, we upload it in OperatorHub.io, so you can visit there, and then we can deploy to your OpenShift or Kubernetes environment. So I will. So the next thing is I will show you like a quick overview. So after you deployed Instana in your Kubernetes environment, what do you expect? Like, so what information we collect, and then see some of the visualization. So I will jump to like a small demo. So along the way, I will jump to a demo. So here we have an demo environment here. So that is how you see when you first log in. It contains all the information about the websites, mobile apps, application, platforms, infrastructure, events. So it's a very comprehensive. So from in one place you can have like an overview. You can see the health of your system. So on the left-hand side here, there is multiple sections, but today we will focus on which do a quick overview about the Kubernetes environment. So right now in the demo environment, we have one cluster, demo EU cluster. So after you deploy the agent, it's automatically collect all of this information. So let's dive into this cluster. So here you see here there is 11 namespace, 3 nodes, 24 services, 38 ports, 22 deployments, 5 daemon set, 1 stateful set, and the health is good. So these are information that is collected automatically, and in the next section we will see how can we actually use this information to dive into our metrics. But for now, just a quick tour. What is the predefined UI that it is out of the box, like out of the box that we have. So here you have like a summary about the cluster. We have CPU request, CPU limits, memory request, memory limits, etc. Right. So down here you can see like also the same idea. Open it, the summary, and you have an overview about your cluster. Like the important metric is there, for example, like CPU resources, memory resources, ports, right? And we have top nodes, top namespace, and deployments. And then we can go also into detail. Here we have component status, debug information. But one thing I like is the namespace here and the deployments. So it lists all of your namespace, all of your deployments. It tells you about replicas, what is available, what is desired. So very detailed, and it's out of the box with no effort in config anything, right? So we can dive into further into the stack. So you can list down here. So you have application tab, Kubernetes tab, and in infrastructure, right? For the quick view application, we can see that we have database. RoboSop is our demo environment. They are all listed here, and all of the service you see here, the Nginx, Redis, all of these are actually listed here. So it's really one center place, and you know everything, right? Cool. So that is a quick overview about what we automatically collect when you deploy the operator to Kubernetes or OpenShift. Right. So we will go back to our slide. Present. Cool. So, as I mentioned from the beginning, our talk today will focus more on metrics, even though Instana has many different kinds of collect and process different kinds of data, like logs and events and tracings, etc. So we talk about metrics in Instana right now, and we will divide that into 3 sections: the problem we solved, and then the subsequent the tool is coming. So when we design the metric system at Instana, so we have to ask ourselves about what is the problem we actually need to solve on behalf of our customer, right? So the first thing is we see that like we know. So the problem is actually the limitation of the early stage metric system is actually it's a static metric system, right? But now our environment is so dynamic. Lots of technologies in use. It can auto-scaling up and down, very elastic, and it's at large scale. So it's no longer a static environment. So if a metric system is static, then it will not work, right? So that is the starting point where how we can design a modern metric system that is also flexible and adapt to a dynamic environment. But let's dive into so what does it mean by static metric system? So what I mean static here is that the metric data are pre-calculated or predefined, and what you put in is actually what you get out. So what exactly it is? So basically, a matrix basically has 3 components, roughly speaking. It has a value, it has timestamp, and it has a name. So basically, it's a time series. You have a list of key value, so a list of pair, timestamp, and value, and then you have a name. The name can be a dot of separate names, or it could be key value pairs tags, where you can do more filtering, grouping, etc. later, right? So a static metric system is where you just, a static system is the system where it just get the data in, store in some data store. It could be any, like could be, for example, like could be Cassandra, and then when at the visualization time, you just get it out and you look at it. So it's really like what you put in and what you get out. So it's like kind of read-only. Not much people can do with it. When you look at the CPU utilization of one server, it's just there. But in the dynamic environments, we want to ask more questions, to look at different angles of our system through metrics, right? And then the metric, the static metric system only work for the environment which is small and also static. For example, like if you have 10 server and you look into the CPU utilization of a server or memory, then it's okay. You can go through every 10 server day by day and look into the system health. It's pretty fast. Not much happened there. But if the environment is dynamic and large scale, you can have like a bigger cluster of Kubernetes where you have maybe 1,000 containers, 100 deployments, and many different namespaces, right? Basically, people cannot look at, if I want to see the health of our cluster, I cannot look into like each individual each individual container. It's just too much, and it's like looking at the picture at the pixel level, right? It is like you look at each individual pixel, but not like an overall picture, right? So that is a limitation of a static metric system. And that's the reason why this cannot be used to monitor a dynamic environments, lots of components, and it's a large-scale environment. So starting with that problem, we have to set our goal. So what we want to do, what our metric systems should be able to do for our customer, right? So the desired metric capability is that our system should be able to allow customer to ask a sophisticated metric question at query time, right? So it's no longer like I load a dashboard with some specific metric about my containers and just that, but I want to ask more sophisticated question by filtering and grouping based on the name, right? So the name is no longer like a fixed string, but it is indexed as a key value pair where people actually can filter it. As you can see from the beginning, in a cluster, we have like namespace, deployments, and pods, etc. So there's multiple parameters there we can filter and grouping. So we can have a different look, different angles, look at the same system, right? So a dynamic metric system has to be able to do so. And the second point here is on-the-fly statistic calculation. So that is very important. Why it is has to be on the fly. So let's take example. Some of the system when let's say when we calculate the latency of some API, for example, right? So people normally look at P99, P99.99, etc. So those is one of the statistics, right? So we have a group of number, and then you calculate the percentile, or you can calculate max, min, sum, sample count, etc. Right? So why it need to be on the fly? So let's say many systems they do a pre-calculated percentile. So you have maybe one host or one container serve maybe serve 100 or maybe 1,000 requests at some period of time, and then you ask a question. Okay, give me the percentile. And then the system will give its own calculated percentile, but only for that specific container, right? But it just happened that the system is a large-scale system, and the API is served by 100 or maybe 1,000 containers, and percentile from one container does not represent the health of the whole cluster. So basically, again, it's like looking at one pixels of the bigger picture. So the on-the-fly statistic is allowed a customer or a system allow customer to recalculate the percentile at the query time. So the customer or the developer don't have to define, hey, I want to get P99, so it has to pre-calculate it. But you can say I want to have P97, P98, etc. at query time, and the data structure behind the scene allows us to do that calculation on the fly, because we just don't know beforehand that what is the question that developers or the user want to ask, right? And the third one is on-the-fly aggregation across space and time. So what does it mean? So the aggregation is basically you aggregate multiple data points into single values that is represent like a set of that numbers. So for example, let's say we have we measure the latency of some API which is deployed among 1,000 containers, right? So if normally the customer want to look at like the percentile of the whole cluster, so what needs to be done is that we need to do an aggregation across all of the containers. So let's say each container will send a data point about latencies, so they all send about the same metric. So we need to be able to aggregate them together. So it's I call it like aggregate across space, because across multiple container, right? And then after the aggregation, we will calculate the statistic like percentile, etc. So what is on-the-fly aggregation across time? So normally when a metric system collect data point, normally they have kind of interval or period. So we collect like one data point every second or one data point every minute, etc. So when the system ingest that data, it needs to store it. So at that time, the implementer of the system has to decide: should I save it like every data point for every second, a data point for every second, or should I aggregate at like 5 minute level, 1 minute level, or 1 hour level, etc., to save time and to speed up the query time, right? But when doing so, basically we have to do a navigation to do so. Like if we have like a 10 data point in a 1 minute bucket, we need to aggregate it together into a 5 minute bucket. But the problem is, if the system decides to do it at the ingestion time, then let's say if you want to calculate the average, for example, so let's say if we have 100 requests and then we take an average of the latencies. So what that is really mean is that with 100 data points, you throw away 100 of them and only keep one single number that is represent for the average. But the problem is that you don't know that average is average of how many requests. So the loss of data actually lost by doing so. So the system had to be able to do on-fly aggregation across time only at the moment when the user query, so that it can reserve the statistic where people can look into it. Because if we take an average of 100 points for 1 minute bucket, and then later I want to have a report to say, hey, I want to see the whole day, what is the average of latency the whole day, then we take all of the average of 1 minute and do the average again, the data is no longer correct. Or if we take like a percentile of each 1 minute and then we group together again and calculate the percentile for 1 day, it will not work. So the metric system have to be designed from day one to do on the fly statistic calculation or aggregation. So I will show you a demo in the later stage. Cool. So how we design our metric system? So here I divide into 4 sections. So the metric model, the ingestion, the storage, and the query, right? So in the metric model, we will talk about like how we want to what is the data structure that we use and why we use that data structure. On the ingestion part, we will talk about like what do we need to do in the ingestion so that it can support all of the requirement to ask a sophisticated question that I mentioned in the previous slide. And also storage is very, very important. Like how do we store so that we can reserve the statistic characteristics so that we can query later, but also in a way how is enable the fast query, right? And then the 4th section is we will talk about how we do the query, right? The query is no longer just go into some data store and get the data out and visualize, right? So it should be able to answer more sophisticated question. Cool. So so how we design our metric system. So the first section is the metric model. So in the metric model, there's 2 important points. The first one is to collect raw data points. I'm going to detail why this is raw in uppercase. And the view aggregable data structure, right? So the first thing is about raw data points. So in many systems, when like a data point is collected, many systems actually do a sampling. So sampling is basically if there's 1,000 data points, we just take a set of it. If maybe 100 data points, etc. Or the system, instead of collecting raw data points, is we do some pre-calculation. So let's say, as I mentioned previously, if you have like 100 data points falling into one time bucket, the bucket can be 1 second, 1 minute, etc. So to report those data points, some system will decide, hey, I want to maybe only report max, min, sum, count, and average. So max means some count average. So basically 5 different values calculated from 100 values. Like, so basically we throw away lots of raw data, and then we just keep 5 data points. But that will affect how we do a query later on. So, but for our system, we need to collect raw data points, because from that raw data points, we will build an aggregable data structure. And why it needs to be aggregable? Because, like as I mentioned previously, we need to when the customer or the user when they want to look at the overview of the health of the system, it's like look at a picture, right? So raw data point is like a pixel. Look at the H pixels, but aggregable data structure is like a picture. That is, you can quickly look into it, look at it, and then have a quickly overview about is our system perform well or not. Right? So data need to be collected in a way that it has to be aggregable, because if it's not aggregable, at query time it will be really challenging. Right? We cannot just do aggregate raw data at query time. That will be too much. Right. Cool. So that is our starting point. When we define a metric model, everything else will like moving around that model. So the way we design the agent, the way we design the ingestion pipeline, the way we design our storage system, and the way we do query, everything is moving around the metric model. So the metric model is the center of the whole metric system. Right. Cool. So the ingestion, the ingestion part. So ingestion starting from the agent. So the agent is the component that get all of the raw data. So in Instana get many kinds of data. It's not only metrics, but logs and tracing, etc. So here focus on metrics. So the agent collect metrics. The metric can the basic metric, infrastructure metrics, or the application metrics, or metric from Drop Wizard, metric from Prometheus, like so multiple source. So the agent is very important because it is a component that interfaces directly with our customer system, right? So the quality of the metrics, I mean, the quality of the whole metric system is really depends heavily on the agent, because if the input data is high quality, then we have high quality output. Otherwise, if it's low quality data, what I mean is that pre-calculated data or sample data, then what we get out later at query time will not be so much more valuable. Okay, so that's why we need to collect raw data points, and then the agent can do an aggregate, do an aggregation right inside where the data is collected. So why it is important? Because let's say when we collect high frequency metric, aggregation inside the agent is critical. So what is a high frequency and low frequency metrics? So normally infrastructure metric like CPU, memory are kind of low frequency. So basically we might collect maybe 1 data point per second for CPU utilization or memory usage. Some systems collect like 1 per minute. So it's not something that we have to sample so fast and collect all of that raw data. 1 minute or 1 second is okay, is enough for CPU utilization or memory, right? But for high frequency metrics, like if you want to capture latency of some API and in a busy host, maybe like 100 TPS transaction per second, like in only 1 second bucket, we already have like 1 data point for 1 metric, right? But if you want to collect maybe 10 metrics, already 1,000 data point, 100 metrics, already like 10,000 data points. So there's a lot of data points there. If we send one of those raw data points to our backend, it will consume customer bandwidth, right? And it's also consume our computation power on our side, because when we receive the data, we have to do aggregation anyway. So we have to look through every single data point and do aggregation, right? So it is more efficient to do it inside the agent and then do further aggregation later. So that is the agent and why it needs to aggregate and why it needs to collect raw data points. So now after the agent get the data points, build an aggregable data structure, and it is sent to ingester, right? So ingester basically is ingesting pipeline. So right now we use Kafka to get the data in, and then we use Kafka partitioning, and then we have ingester as a consumer, which can consume from Kafka, and then it do more aggregation. So why do we care about aggregation ingester? We already have aggregation in agent. Why we do really care about also ingester? Actually, this is very important. The reason is the metrics can be aggregated at the agent, but multiple agent from multiple containers might or normally or they can publish exactly the same metrics. So for example, let's say if somebody wants to publish like a custom metrics, like a counting of some customer activity, maybe the customer maybe view a product or something. So each container will publish the same metrics, right? Exactly the same metrics, but they come from different source. So the job of the ingester is actually aggregate them together, right? So container A produce a metric about the number of times the customer order. Container B also collect the same thing, and then they hit into the same partition, and then it's go into the same ingester, and the ingester have to put it in the same bucket. And if they're in the same time bucket, then you have to put in the same time bucket also. So you have to do more aggregation, so that when at later time, when the user look at the metrics, it is the metric that represent the whole cluster, right? But of course, we will talk about also if the metric have like have a tag like maybe a container ID, then we will need to talk about aggregation at the query time later. But the ingester have what I mean here is ingester also can do aggregate on the way in, and it's very efficient, and it's also really good to speed up at query time. All right. Cool. So the next one is after we ingest the data in. The next thing is we need to store it, right? So after ingester, we have a component called aggregator. So aggregator will consume data. So the ingester will push or aggregator data to aggregator to do more aggregation if necessary, right? And then that aggregator will play a role. It's also persist data. And it's also the entity that can allow people to actually query data. So we need to. So how can we actually store our data? So let's again the storage similar to the agent or the ingestion part. The storage part also designed with the aggregable data structure or the metric model in mind, right? So what do we store? So we store, as I mentioned from the beginning, the metric have it can be the two components mainly: the metric name and the metric data, which is the pair of timestamp and value And then, of course, we convert into an aggregable data structure. So those two components need to be stored. I mean, store here is also indexing, so that we can do like a fast query later. So for the name part, so the name we keep it as a key value pair. So let's say a metric about CPU utilization of container. We will have a container ID there. We have a namespace. We associate deployment there. So multiple key value pairs actually attach to the metric CPU utilization. So you should have more context, and people can actually do filtering and grouping later, right? So those metric names are stored and processed separately, because it's just so different from metric data like the timestamp and the value. So they're very different. So the way we index the tag name is also done separately, right? and for the aggregable for the metric data, we keep exactly the same aggregable data structure. So basically, what aggregatable data generated by agent is exactly the same as the aggregable data produced by ingestion, and it's exactly the same the format that we store the store to disk, right? And because we want to store our own format, and we have to come up with our own storage layer. So we tried a different way to store it, but it is end up that we implement our own storage layer where it can allow us to do a fast append, fast lookup. But importantly is that it's tailor-made for the aggregable data structure, right? Because that is a data structure that allows us to do more sophisticated query, right? So we also custom the storage part. Cool. So after we collect data from agents, we send it to ingest. We do more aggregation for on the way aggregate for metric that the similar metric come from different source, and then we store it. Okay, so the metric come all the way from the customer system and to our disk. So the next step is how can we query it? The idea here is that the query need to be flexible, so that the customer can ask sophisticated question, right? So to do so, we break down the query process into multiple stage, right? So when customers send in a query, actually it's been processed in multiple steps until it is returned the result. So the first thing it does is it's a filtering tag, right? So it is very important because there are 100 million of metric, and we don't want to touch the metric data part, because it store timestamp and data, but it's really heavy. And we don't want to touch it first. We want to touch the naming first, because that is where people want to do filtering. It's like similar in like SQL. When SQL execute, we execute the where clause first, and then filtering the rows, and then after that we do further processing, right? So same here. We do filtering the tags. I will have a demo later. Specify the key value pair, and then it's quickly reduce the number of time series to look at. For example, like people can select, hey, I want to look at a specific namespace, Kubernetes namespace. I want to look into specific deployments. So that's really has to be the first step before we do anything else. So the filtering here is actually also I want to include also the grouping. I should add the grouping here also. So the grouping mean is that so let's say let's say we have we measure an API latencies where it's deployed into multiple containers, but we want to aggregate by deployment, for example. So basically, we remove the tags about the tag that has a container ID or port name, etc. Basically, we just remove that. So basically, we end up with like a bunch of time series. Now it's look identical because the different spot is already removed, right? So now they only contain maybe a namespace tag there. So that is a moment where we need to group them all together, right? So that is a grouping part, and that grouping part is also affect the later steps. So so the next step is to calculating statistics. So the statistic is the value calculated from aggregable data. So for example, looking at an aggregable data for a specific metrics or at a specific time bucket, I want to ask a question, hey, give me a max, give me a mean, a sum, count, percentile. So those are statistics that we can ask from the aggregable data format, right? So we need to ask it first before we do any calculation. So that is the next thing. And how we calculate the statistic is really also depend on the grouping part that I mentioned in the previous step. So for example, let's say I want to get a percentile of API latencies, and if I have like 1,000 time series, so without the grouping, I will need to calculate the percentile from each individual aggregable data for each time bucket and for each time series in that 1,000 time series, right? So the end up is that we will have like 1,000 time series display on the dashboard. It's just too much. It's just an exaggeration to say that is might not something that that user want to see. So the grouping will tell the calculation step, say, hey, I want to calculate the percentile for API latency, but for maybe for that namespace. So before calculating the statistic, the system need to build an aggregable data structure from those individual time series, right? So before we do any statistics calculation, we need to build, and again, we need to build on the fly the aggregable data structure first. And then after we have like a single aggregable data structure that's represent for 1,000 time series, only at that moment we will ask the question, okay, give me the percentile. Then it will calculate the percentile, which is represent for 1,000 metrics. So that is a calculating statistics step, right? And then the next thing is about distributing the calculation. So every component in our metric system is horizontal scalable. So the ingestion pipeline, also the aggregator part, is also horizontal scale. The benefit is that, of course, it scale with the lots more customer put in more metric. We just need to add more hosts. And also the benefit is that we can distribute the calculation at the query time, because then we can utilize concurrencies, right? So to do a calculation, so let's say if a query is sent in, if you need to process 1,000 of metrics, and those metrics actually span across multiple instances of the aggregator. So that is a good thing, because then when one aggregator receives a request, it can do a fan out request to all other aggregator that contain that metrics. So all of those aggregators will contribute to the work, and they do calculation at the same time. So you can have a good parallelization, right? So we can utilize all of the CPU core that we have. So that's really good. So one central aggregator will fan out that request, each individual do calculation, and then it will send out send in to the central aggregator, and then that central aggregator will finally do a final calculation, view a JSON format, and then send to the customer through UI, of course. And the aggregator center is actually is randomly chosen. If the request land into one aggregator, then that aggregator will be the central aggregator for that specific request only. And then if the requests go into different one, and it's different one, will take the ownership of do a final calculation before return the JSON response. Okay, so the next thing is also the Lua code that we put into our system. So you might know that Lua code is a scripting language. It's really a fast execution. It's easy to embed, and the learning curve is very short because it's simple. And the idea of having Lua, bring Lua into our system is we can bring the logic is actually inside the Lua code to the data. So we don't pull the data from our aggregator to do calculations elsewhere, because then so let's say, assuming if you want to do like to do like a top 5 of like a server 1000 metric, we don't want to get own 1000 metric outside and do a sort and get the top. It's just too expensive, right, for computations and so bandwidth, etc. So by bringing the Lua code into the aggregator, and then aggregator actually distributing the calculation is distributing the Lua code into different aggregator at the same time. So owner of the aggregator execute a Lua code, do a calculation, and then finally is pack all of the result into a JSON format, or for example. But the idea here is to do the calculation where the data is, and instead of getting data out, we just distribute the Lua code everywhere and then execute it. Right. Yeah. I think that is the main thing for the query. I think that's the end of the slide, and now I will go to a demo to talk about the query side of it. Right, we will not be able to see the ingestion, the agent, or the storage, but we can see the query, which is exposed through our UI. So we go to here. So in Instana, we have a custom dashboard. So custom dashboard is the dashboard that allowed a customer to create their own chart. You can plot their own metrics, right? So it's different from the built-in dashboard where you see what you see is here, right? So you have a predefined dashboard. You get a great detailed overview, both details and overview of your health of the system. But yeah, you cannot manipulate it. So that's why we provide a custom dashboard where you can actually create your own metrics based on your needs, right? So our dashboard can actually present data from metrics, from tracings, and many other different kind of data, but let's focus on metric for now. So let's create a new dashboard. So we're in dashboard. Okay, so create that. So it's blank. So the first thing we need to do is to add a widget. So the widget is here. So multiple choice here. You can display the widgets as a big number, as a pie chart, as a time series, markdown, SRO, time zone, and top list. So multiple choice that fit into multiple needs from our customer. So let's select a time series chart, and we go next. Right. So this is the UI where we can actually build the query, right? So you see here, the first thing we need to do is to select data source. So data source, you can have 5 different choices here. Application for tracing endpoints and events, infrastructure platforms, mobile app, and website beacons, right? So today we focus on infrastructure and platforms. That is where we store metrics from our infrastructure, CPU memory, container, etc., and also service metric from Drop Results, Prometheus, etc. So we select that. So here we have a metric section, aggregation section, filter section, group, time sieve, etc. Right. So the first thing is if you select the metrics, you see a drop down here, and the drop down contains it's a comprehensive list of one of the technologies discovered by our agent automatically. So we have .NET, we have AWS, Azure, container, etc. So and for each of the components, it's a section you can dive in further, and then you can see more metrics like I just click on Docker container, you see block IO, CPU, etc. So that is the metric name that I mentioned previously, right? So the name is processed separately. So what we are doing here is the first stage of querying. You just interact with the metric name, basically that. Talk to the metric service, the name service, and then return a metadata or the metrics, and then represent in a way that's easy to access, right? Okay, and down here, okay, so it's not selectable because I need to select the metric first. Yeah, I can do it later. So now the filtering, as I mentioned, the filtering part is that you want to look at some specific part of your system, because you want to narrow down what you're interested in. So maybe I search for namespace. Okay, so I select a cluster also. So I filter by cluster name, and then here you see that there's a demo EU cluster that I show you from the beginning. So we have one cluster, so we select that. So what's happening here is that the system will talk to the tag service. Hey, I want to filter only the cluster with the name demo EU cluster. So it's filter out all of the metric that's only contain that key value pair. And then after that, down here, you see that it has less option because now it's narrowed down. Right. And then, of course, from there, you can select maybe the CPU user, for example, right? And then after that, now it is the statistic part. So if you remember that, so the next step is that we need to ask a question from the aggregable data, hey, what is the statistic that you want to look at it? So we have max, min, sum, percentile, etc. Right? And they are all calculated on the fly. So the data structure store there is not P95 is store or not min max store. It's actually the aggregable format. And then now when I click a button, then later it's been asked a question. So I say I want, okay, get me the mean, right? So then when I select that, I have one line, of course. So by default, is do the grouping by default already. So if you don't specify it, the grouping here is the default is group everything. So what you see here is that it's grouping every container belong to the demo EU cluster, right? And that's happen is the grouping happened first, and then the aggregation calculating the statistic of the average will kick in and generate this data for you. And of course, you can put a CPU user here, and then you have a title here. Okay, so we can quickly create that, but I want to quickly show you one more thing. Is when we do it again, we go to the time series, we select the infrastructure platform, and then again we select, I just do it quick because I'm aware that we're running out of time soon. So we have cluster again, and then we select that. Okay, so what I do different here, so I just select the CPU again. CPU user, where's that? Here we go. So I select aggregation, done. So what I do differently here is I want to do a grouping. So I want to say like a pod. I want to say I want to get a pod name. I want to get a top 5. All right. So right now immediately you see that it's grouped by the pod name in that namespace. So basically the same data, but you look at the different angles. And now it's all calculated on the fly, and I can show you, instead of looking each individual pod, you know immediately what is the high CPU usage pod, just immediately. And of course you can just for fun, we can do a deployment, also deployment name. And then we can see, okay, so we have MySQL, catalog, RabbitMQ, etc. So the same mechanism, processing the metric name first, doing grouping if necessary, and then ask the arguable data about statistic, and then do further calculation. So the Lua code is not exposed through the UI. So we are building expose more functionality to the UI in a coming version. But behind the scenes, it is using the query system that I just discussed with you before, right? So so that's it. So that is so this is my demo. Thank you very much. And if you have any question, yeah, please feel free to send in. Thank you, slide.
Awesome. Thank you so much. That was amazing. All right. So unfortunately, it doesn't look like we're going to have time for questions, but please know if you did have questions for Trung and you sent them in, we're going to gather those up, send them over, and he'll be able to answer those for you offline. I do need to remind the audience that this was recorded. So if you missed any or all of it, or you just want to go back and watch it again, we'll be sending an email with instructions for how to access the webinar on demand, or you can always visit us at devops.com/webinars, and you'll be able to find it there. And so now it's time for me to announce our winners for our Amazon gift card drawing. I went ahead and grabbed those just a few minutes ago, and our winners today are Daniel P. Congratulations, Daniel. Reza S. I apologize if I'm pronouncing that incorrectly, but congratulations to you. Victoria G. and Chrisanne N. Congratulations to all our winners. You will be getting an email with instructions for how to claim your gift cards. If you don't see that come through your inbox, please make sure and check your spam folders. All right. Well, thank you very much to the audience for joining us today. We really appreciate your time. Thank you so much to Trung for that amazing presentation. We hope to see everyone back again soon at another webinar. I'm Sharon Florentine, signing off.
Thank you very much.